Hi there, we're going to do question 6. This is essentially on acids as well as salt preparation, and this is worth 8 marks, so let's deep dive into things. So the first question is essentially a MCQ question or multiple choice. You need to identify why is hydrochloric acid acting as an acid. So what is the definition of acid here? Acid is a proton donor. What it does essentially is if you it give away the proton, which is H+, okay? Give away. And one thing about acid is, are you able to recall the 3 common acids? Well, actually in iGCSE I find that they prefer the first 2, hydrochloric acid and sulfuric acid. These are the formula, but I personally like to also include nitric acid because of the solubility of nitrate ions. Okay, so these are the 3 common acids, and if you could take a moment to appreciate them, all of them have something in common, and that's the H. And when they all dissolve in water, they were ionizers. That means they will split up into the H+ ion and the other part. So basically what this means is it will split for hydrochloric acid, it will split out into H+ and Cl-, etc. Okay, so acting acid is a proton donor. That's what you need to know. Next thing, take one observation made during this reaction. Which reaction is this? We are putting a piece of magnesium into hydrochloric acid. Oops. And because magnesium is our reactive metal. Okay. So when you have metal and acid coming together, you always end up with a salt and hydrogen gas. So they are asking for observation, basically what you can see, right? So take a look at the product. The product is one of the things that comes out is a gas, but if you write gas produced, you actually won't get any marks, right? Because we are not asking you for explanation, we are asking you for observation. What can you see if gas is produced? You basically see effervescence, bubbling, or fizzing. Okay. Over time, you also see that the magnesium metal dissolve or you get smaller. Any of this, you would actually get you the mark. Now, one thing I find really interesting is that this year, so much changes, right? They accept the idea of something getting warmer. Now, this reaction is essentially an exothermic reaction. That means it gives out heat. So one of the observation you actually get is the reaction gets warmer. However, this is one thing that I've noticed in the past year, they don't accept things that do with feel, right? So when I first taught iGCSE, I thought an exothermic reaction would be able to increase the temperature, and therefore an observation that is possible to, that's identifiable would be the heat, the warmth, right? But in the initial years, the first few years, they don't really accept that, right? So this is the first time I see this as a potential possible answer in iGCSE. Okay, but of course the most obvious change is because of the gas produced, you get effervescence, bubbling, or fizzing. So if you're ever stuck, okay, use equation to guide you. This equation is what I call datas. They are clues, they are contextual clues, like what you do in English. In the passage, in the whole passage, you look for contextual clues. It's the same. Chemical equations here is the contextual clues to help you solve a question in chemistry. Right, next question here. Give a reason why students need to add excess magnesium to hydrochloric acid. So this student is trying to prepare this salt called magnesium chloride, and you could see that the student here add excess magnesium powder to hydrochloric acid. Now, in order for you to appreciate this, I have a image here. Okay, so what we want to do is we are trying to prepare the salt. Now, in order to prepare the salt, if you have any solid here, if you can look at the extreme left hand side, okay, unfortunately I can't draw on this, yeah, sorry, okay, is that we want to add an excess of solid like metal or metal oxide or even hydroxide or carbonate. The reason is because we want to make sure that the reaction is complete, the reaction of the acid is complete. Why? Okay, we want to make sure this happens. It's because if there is still acid remaining, okay, if there's still acid remaining, then we will not be able to tell, right? If there's excess acid, it will be coating the salt that is formed, but we will not be able to tell because they're both colorless. However, if you add in excess of a solid, right? If the solid cannot dissolve anymore and you see like extra solid, like no matter how much you stir, it is still there, that basically shows that hey, the acid has fully reacted, and the salt form would not be contaminated by the excess acid. Okay, so the main reason why we want to always add excess solid to an acid is to make sure that all the acid has fully reacted. Okay, so that the salt form would not be contaminated. This is the bigger reason, but this is optional. You don't have to write this. Okay, finally, this is a 5-mark question. This is more of a memory question in my opinion. You need to be able to write this step word by word and step by step, and this is under salt preparation. Okay, so under salt preparation there are 2 main types of salt. We have got soluble as well as insoluble, and under soluble we've again split. One is spar salt, and then these are the non-spar salts. Okay, so what we have here is magnesium chloride. It's a soluble salt, but it's non-spar. So what we start off with is we have the excess magnesium. So how this will look like here is you have your mixture like this. You have your extra solid. Okay, so your extra solid here. So this is your excess magnesium, and your salt, your magnesium chloride salt that you want is inside here. So they are saying what should a student do to this mixture. So you have this mixture right now, and what should you do next? The first thing you want to do is to remove the excess magnesium. So that's essentially your first step. Okay, remove the excess magnesium, and what you will get here is, after filtration, I hope you know how to draw filter funnel. Sometimes they do ask students to draw. Okay, so this is the excess magnesium, but essentially what you want here is your magnesium chloride solution. So with this solution, what you're going to do is you're going to heat the filtrate. Okay, so whatever that is collected at the end of a filtration is known as a filtrate. You want to heat the filtrate here until you get a saturated solution. If you find the word saturated solution is really hard, an alternative answer here is to simply say that heat until crystal first start to form. That these two are either or. You don't have to write both. Okay, so that alone will have gotten you 3 marks. So 1 mark here. Filter to remove the excess solid. In this case, the excess solid is magnesium. Then you want to heat the filtrate until you get a saturated solution. That's 3 out of 5 marks already. And what do you do next then? Okay, so if I could point out to you, so step 1 to 3, it's basically what you see here. Is there a way I can draw this? Okay, no, I can't. Okay, it's the second last diagram. Okay, you will heat until you get a saturated solution, and then you will off the Bunsen burner. The reason why you want to off the Bunsen burner is you want to allow the crystals, the solution, to cool and crystallize. Okay, so when it reaches this step, how it will look like is you got your basin and you got your crystals, and you still have a little bit of solution left. But what you want at the end of the day, you just want pure dry crystals. You don't want any solution there. Therefore, you need to filter again. So when you filter again, I'm just going to use this. Okay, when you filter again, what is happening here is you only get the crystals. Okay, so the step number 4, the next step here is to filter to obtain the crystals, and you want dry, isn't it? You want to make sure it is dry. So what you can do is you can either put it in a warm oven, or you pet between filter paper, or you can just simply leave it to dry to make sure you get your crystal at the end of the day. Okay, so just leaving the screen over here to help you appreciate the step-by-step procedure on how you can get a soluble salt that is non-spar, because with spar salts you need to do the process of titration. Okay, so let's pause here. So 8 marks here. How is things going? I think I will try to find a better diagram that I can annotate. Maybe I'll get a diagram and I can paste it on my PDF. So as I explain, I will be able to use the diagram to help you visualize the step-by-step of crystallization. Alright, see you in the next one.